Okay, welcome to example number 4. We are still doing the proof involving sets. And in example number 4, we have a very long statement that we need to show that two sets are equal. So again, if we want to show that two sets are equal, we have to show that the first one is subset from the second one, and later we need to show that the second is subset from the first one. And usually, if we have a long statement to prove involving sets, sometimes it might be easier for us to work on each set separately, trying to analyze it in a separate way and see if we simplify them, we get the same statement. That's, again, an easy way. We can do it the usual way by proving one set is subset from the other and the second is subset from the first, or we can just do it in this way. So what I will do is I will just do it, both of them I will at the same time. So let me just take the screen here and let me focus on this one. So let x in the intersection negative c. This has a meaning. It means that x is in the first one and x is not in the second one. And now, something in the intersection, it has also a meaning. X is in A and x is in B, and finally, x is not in C. So here we have three information, very simple. We know that x is in A, x is in B, and x is not in C. Let me now go to the other direction and try to simplify it a little bit. Do we get the same thing, same three information? So if we take something like this, it means x is in the first one and x is in the second one. Okay. Which means x is in A and x is not in C, and x is in B and x not in C. Now, do you see that there is something redundant here? So I don't need to write it twice, so I will just write it one time. Now look at the last two statements. Are they the same? Let me just highlight them to you. Look at this one and look at this one. These are equivalent. They are the same statement. So the two sets must be equal, must be the same. If we do one subset from the other, that's what we will get. We'll get this here, so it's here. Just go the steps from top to bottom. And again from bottom to top, if we want to do it the old-fashioned way. They are the same statement, so sometimes simplifying the question can help, and helps a lot in figuring out what is going on and how each statement is going. Let me apply the same statement for this question here, and let's see if we get the same idea. In this set here, a question that involved the Cartesian product. So we have to be a little bit careful here. So let me just maybe do this side first. A cross C intersection B cross C. So here, because I'm talking now about the Cartesian product, so I need to take something that consists of a pair of two elements. So let x comma y belongs to here and here, which means this pair xy belong to the first set, and also the same pair belongs to the second set. Now, if we analyze the situation, this means x is in A and y is in C, and x is in B and y is in C. Now, I think this can be simplified to x is in A and x is in B and y is in C. This is, I think, what we can simplify it into. We will keep it here. Let's look at the other side and see if we get the same statement or not, which means they are equivalent. Again, we use this method if we want to show that two sets are equal and they are a little bit complicated. And instead of showing each one subset of the other, we can just simplify each one and see if they give me the same equivalent statement. So here is this part. So let x comma y belongs to A intersection B cross C. This means the first one, which is x, must be here, and the y must be here. Now this means x is in A, and x is in B, and y is in C. Which I think it's exactly the same statement as the other direction. And they are equivalent, so they are equal. Thank you for watching this video. Please like and subscribe.